are atoms? Atoms are the smallest unit of any element, okay? What is present in atom, or what is atom made up of, okay? Let's discuss in detail what are the protons, neutrons and nucleons, what are their charges and their masses. Here we understand how do we represent any element, okay? How do we represent electrons which are arranged in the shells, okay? So we can also write electronic configuration for ions. Now what are ions? Hello and welcome back students to yet another exciting chemistry class with me. So if you are liking the videos and the videos are helping you to understand the chemistry concepts well, then don't forget to like the video, subscribe to our channel and share it with your friends. Let them know how you are understanding the chemistry concepts so well. Okay, so today in this class we will be discussing about isotopes and we'll learn how to calculate the relative atomic masses. We'll also try to understand what is the difference between the mass number and the relative atomic masses. So let's begin. So what are isotopes? Isotopes are those atoms which have same proton number but different mass number. Why the mass number changes? Because the number of neutrons changes. Okay, let's quickly give a read to it. So isotopes are defined as atoms of same element. Okay, they are atoms of same element. It means that the proton number remains the same, that have the same number of protons but a different number of neutrons. Okay, now because the number of neutrons are different, it means the mass number will also change, because mass number is nothing but the addition of number of neutrons and protons. Okay, next, this means that isotopes of an element have same atomic number but different mass number. Okay, for example, let's take up an example of carbon. Okay, so carbon have 3 isotopes. Okay, so the first one, which is the most abundant amongst all, is carbon 12. Okay, I can write it like this: C6 and 12. Okay, this is the most abundant isotope of carbon with 98.9% abundance. Okay, another isotope of carbon is carbon 13. So if you can see over here that number of protons remain the same in this case, okay, but the mass is changing. But now how mass is changing? Mass is changing because in carbon 6 with the mass number 12, the number of protons are 6 and the neutrons are also 6, and that adds up to give me the mass number 12. Okay, but in case of carbon 6 which has mass number 13, in this case the proton number remains the same, which is 6, but the neutron now changes to 7. In case of this, the neutron is 6. Here one more neutron has been added and that makes the change in mass number. Okay, so the new mass number is 13. Okay, so the chemical properties of these two isotopes, which is carbon 12 and carbon 13, is almost same, but the carbon 14 chemical properties is different. Why? Because it is radioactive in nature. Okay, it is found in very trace amount and it is radioactive in nature. And let's check the mass number and atomic number also. So the atomic number remains the same because the proton numbers remain the same, which is 6. Okay, and the mass is 14 over here. So that makes my neutron number to be 8. Okay, so this is how we define isotope, or we understand isotopes, that the atomic number or the proton number remains the same. In case of carbon, the proton numbers remain the same in all these 3. Okay, but the mass number is different. Why the mass number is different? Because the number of neutrons is different. I hope this is clear. Now let's move to your next slide. So this tells me the key points to understand what are isotopes. So let's just quickly give a read to it. So the atomic number, which is also known as proton number. The number of protons in the nucleus of an atom, this number is the same for all atoms at a given element. Okay, so the number of protons remain the same as we have discussed. What about the mass number? The mass number, the total number of protons plus neutron. Now mass number is nothing but protons plus neutron. I am saying that protons remain same. So what is changing? To change the mass number, neutron numbers are changing. Okay, this is changing, and hence it is making my mass number to change. Okay, so since isotopes have different number of neutrons, their mass number differ. Okay, so why their mass number is different? Because they have different number of neutrons. Next is your chemical property. Now what about chemical property? Are the chemical properties of all the isotopes same? Yes, the chemical properties remain similar in all the isotopes. Why? Because they have identical chemical property, because they have the same electron arrangement. For example, in case of carbon 12 and carbon 13, what happens? The proton number remains the same. It means the electron number should also remain the same. Why? To keep the atom neutral. Okay, that is why the proton number and electron number remains the same. So in carbon number 12, the atomic number remains the same, which is 6 and 6. Hence, I can write the electronic configuration as 2, 4, and here also 2, 4. Both of these isotopes have same number of electron, which is 4 in their outermost shell. Hence, the chemical properties remain the same. But I gave you an exception, which is this one, carbon 14. Why? Because it is a radioactive isotope. Hence, it shows a different chemical property. But both of these show similar chemical property. Okay, similar chemical property. Now, your last point is physical property. What about physical properties? So, physical properties can slightly change, like for example, density and melting point can change as the mass changes, okay? Because we all know that as mass changes, the density also changes. If mass increases, then density increases, and hence the melting point can also change. So, isotopes may have slightly different physical properties such as density and melting point due to their differing masses. Okay, so the physical properties which are related to masses changes. All right, now let's move to another slide, which is mass number and relative atomic mass same? Okay, so what is mass number? You must have seen that when we write chlorine, we write it something like this. So chlorine 1735, and another isotope of chlorine is chlorine 1737. Okay, but when we write the relative atomic mass of chlorine, we write 35.5. So can I say the relative masses can be written in decimal number, or it is not necessary that the relative atomic mass is a whole number, but the mass number always is a whole number. Okay, the mass number always is a whole number. So now what is relative atomic mass? Relative atomic mass is the average of the masses of isotopes. Okay, so all the atoms which shows isotopes, they have different mass number. So what do? We calculate the average atomic mass of these isotopes, and then we consider that mass as their relative atomic masses. Okay, so the formula to calculate the relative atomic masses we'll do in your next slide. Before that, let's just quickly read. Mass number. The mass number also called as nucleon number. What was nucleon number? The sum of protons and neutrons. Of an atom is the total number of protons and neutrons in its nucleus. It's a whole number specific to each isotope of an element. So this is important. Mass number is a whole number always, okay, and it is specific to each isotope of an element. For example, chlorine 17 has mass number 35. Another isotope of chlorine 17 have 37. Okay, so this is specific, and this is always going to be a whole number. But what about relative atomic masses? The relative atomic masses of an element is weighed average mass of all the naturally occurring isotope of that of an element, measured on a scale where the carbon 12 isotope has a mass of exactly 12. This value can be, this is important now, this value can be a decimal. Okay, like for example, chlorine average atomic mass is what? Relative atomic mass is what? 35.5, and reflects the average mass, not the exact count of protons and neutrons. I hope this is clear. Now let's understand how do we calculate the relative atomic masses. Okay, so for example, let's take up an example of chlorine. So chlorine have two isotopes, chlorine 35 and chlorine 37. Okay, so chlorine 35 is naturally abundant with 75%. Okay, and chlorine 37 is 25%. These are their natural abundance. Okay, so now let's put the values in the formula and let's check how do we calculate the relative atomic mass of chlorine. So to calculate the relative atomic mass, what do? We simply multiply the percentage with the mass of the isotope. Okay, so 75 multiplied by 35 plus the second isotope, which is chlorine 37. So 25 multiplied by 37. 25 multiplied by 37, and then the whole divides with 100. Okay, we'll be dividing this by 100, and then at the end, after solving this, we'll get 35.5. So I can say that the average or the relative atomic mass of chlorine atom is 35.5. Okay, if I talk about chlorine 35, then the mass number is 35. Mass number is 35 and the mass number of chlorine 37 is 37. But on average, if I have to calculate for chlorine atom in which all the isotopes are included, then what do? We find the average relative atomic mass, which can be a decimal number also. Okay, not necessarily that it will be a whole number. So over here we find 35.5 as its relative atomic mass. Hence, one more thing which we can say from this point is that from your mass number we can calculate the number of protons and neutrons, but from your average relative atomic mass, which is 35.5, we cannot calculate the mass, the proton number and the neutron number. Okay, similar point was given previously on this slide. What was the point? That the relative atomic mass is weight occurring isotopes measured on a scale of, okay, so isotope has a mass of exactly 12. This is the value of and reflects the average mass, not an exact count of proton and neutron. This is the point I'm trying to explain over here. Okay, so the mass number can help me to calculate the number of protons and neutrons, but the average relative atomic masses do not help me to calculate the protons and neutrons. It simply tells me the average of the mass of the isotopes. Okay, now let's move on to your question. So the question says the table shows information about the isotope in a sample or rubidium. Okay, so two isotopes of rubidium have been given to you. First isotope is with the mass 85 and another isotope with the mass 87. Okay, and the natural abundance is given to you in percentage, 72% and 28%. And the question says use information from the table to calculate the relative atomic mass of the sample of rubidium. Give your answer to one decimal place. Okay, so like how we did for chlorine, similar formula and similar way we have to apply for rubidium also. And take a minute over here, pause this video and try doing this question on your own, then we'll discuss. Okay, I hope you have tried doing this question on your own. Now let's try. So the formula to calculate relative atomic mass is what? We'll simply multiply the natural abundance with the mass number first. Okay, so for the first isotope, the natural abundance is what? 72 multiplied by 85, okay, which is the mass number of this isotope, plus 28 multiplied by 87, okay, and divided by 100. So if we'll solve this, which we'll do now, so 72 multiplied by 85 gives me 6120 plus 28 multiplied by 87 gives me 2436 divided by 100. So let's calculate. 2436 plus 6120 gives 8556. 8556 divided by 100. Okay, so if we'll divide it by 100, we'll get something is this, okay, approximately 85.56. So we can say that the relative atomic mass of rubidium is what? 85.56. Now from here you can quickly note down the solution as well. Let's now move on to the next slide, in which I have 3 questions for you. If you wish to pause here and take a screenshot, or you want to do this, try this on your own, well and good. So the first question says an atom of neon has 10 proton, 10 electron and 11 neutron. How many nucleon does it contain? So you should know what is nucleon. Nucleon is nothing but a name for proton plus neutron. Okay, collectively protons and neutrons are known as nucleon. So protons plus neutrons. Okay, the numbers have been given to you. Protons are 10 plus neutrons are 11, which gives me 21. So this becomes the nucleon number, which is 21, or I can say the mass number. Okay, because mass number is nothing but proton and neutron, the addition of proton and neutron. Next is, what is the difference in terms of subatomic particles between an atom of chlorine 35 and 37? Okay, so the subatomic particle which is different in chlorine 35 and 37 is what? Chlorine 35 and chlorine 37. So previously only I told you that atomic number of chlorine is 37. Okay, the atomic number or the proton number remains the same for an isotope. Okay, the mass number changes. For the first one is 35, for the next isotope is 37. Okay, so how do I calculate the neutron number? This is the mass number, which is the addition of proton and neutron. This is the proton. Okay, so 35 minus 17 is how much? 18. Okay, so 18 is number of neutron in which? In chlorine 35. Okay, number of neutron is 18. What about number of neutron over here? It will come out to be 37 minus 17, which will be equal to 20. Okay, so the number of neutrons is different. Okay, number of neutrons is differing in chlorine 35 and 37 with these numbers. Okay, the last question is, by considering the subatomic particles present, explain why as atom of nitrogen is electrically neutral. Okay, why an atom of electron is electrically neutral. So why any atom of or why any atom is electrically neutral when it does not have a charge over it. Okay, and when does that happen? When the number of proton is equal to the number of electron. Why? Because protons are positively charged species, right? And electrons are negatively charged species. So if the number of protons and electrons are same, it means that the atom will be neutral. Okay, the positive charge will neutralize the negative charge. Okay, it doesn't have anything to do with the subatomic particle neutron. Why? Because neutrons are neutral. Okay, they do not have any charge, they are neutral. So I can say that nitrogen is electrically neutral as it has 7 protons. Okay, the atomic number of nitrogen is what? 7. Okay, and 7 electrons. Okay, hence the positive and negative charge species are same, hence the atom is neutral. Hence the atom or the nitrogen atom is neutral. Okay, now quickly write the correct answers down, students. So here we come to the end of the topic isotopes. I hope this is very much clear to you. The concepts are now clear and you can do the questions of isotopes and how do we calculate the relative atomic masses. In next video, we'll understand that what are ions and what is ionic bonding. Okay, what is ionic bonding and what is covalent bonding. Till then, keep learning and enjoy. Thanks for watching and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.